Hello, welcome all of you. Welcome students and welcome all of you to our YouTube channel. This is GatePro by Suresh VSR. We're into gate coaching in EC and electrical. And this is my video in YouTube after 18 months. That means in the last 18 months, after some of my videos in August 2024, I have not done any video because it's because I felt YouTube is complete in itself. I did not want to add any new information in YouTube. And the last video I did was on VLSI and opportunities in VLSI. After that, I did not do any video, but now I felt there is a small necessity of doing a video. The reason is I wanted you to understand what are the topics that you have to learn for GATE, or what is the topics that you have prepared, and let's see what you are supposed to actually have as a checklist. Maybe it's for students who have prepared all the subjects, or maybe two subjects or three subjects. Have a checklist of what are the questions and what can you expect about it. So it's a small video on GATE EC 2026. Check out the topics that you're supposed to actually prepare or see what sort of questions can be expected. So broadly, I divide GATE syllabus into three topics. The aptitude part, beginning, the simplest, basic, the engineering mathematics part, and the core electronics, the core subjects. With the weightage being approximately for 65 questions, with 100 marks, 30 to 1, 35 to 2. This is, I hope all of you know. So 30 to 1 mark questions and 2 mark questions of 35 makes it 70 plus 30, that's 100 marks. So 100 marks out of the 65 questions. Aptitude is very clear. 5 1 mark questions, 5 2 mark questions, which includes reasoning aptitude, numerical aptitude, verbal aptitude. So there could be some calculations, there could be a diagram from which you would interpret, or it could be non-calculations based, non-number based, whatever it is, 15 marks. Right? This is damn clear, 10 questions. Then, of course, mathematics is also very clear with 8 to 9 questions, approximately 8 to 9 questions, with around 13 marks. So, could be in the form of 5 into 2, or 4 into 2, or 3 into 4. So, around 5 questions of 2 marks, 5 into 2, not 4 into 2. So, 10 plus 3, or it could be 4 and then 4 there. It could be, that's approximately depends on 8 to 9 marks. So 8 and coming to 10, 18 questions almost reserved. So you have to handle in technical in your core for 47 questions. Let's say approximately 47 questions, subtracting from 65. So 10 and 8, 18, and then 65 you subtract 47 questions, and 72 marks is your core electronics. So let us look at what will be your 72 marks and what will be the weightage of these 72 marks. So mathematics also I'll tell you what topics to go through. Aptitude, yeah, it's very clear that you have to go to reasoning aptitude, you have to go to numerical aptitude and verbal aptitude. So let's look at what should you handle in mathematics. Let's see what will be the questions that you're going to handle in mathematics, or what are the areas that you're supposed to focus on mathematics. So, mathematics, the first topic, you have to be efficiently good at matrices, finding out the rank, determinant, solving some applications of matrix through differential equations. So, matrices, expectedly one or two questions you can expect. So, the first is understanding of matrices, determinant calculations, or rank calculations, or simple problems. The second topic is calculus. Basically, you have to answer limits, something clear to your link to your 12th class. So it's about limits, derivatives, not vector calculus, simple derivatives, maximas, minimas, applications, two-dimensional integrations, surface integrations, volume integrations, line integrations. So around another one to two questions you can expect. So matrices followed by calculus is the first level of clarity. Then vector calculus, where you have to handle something beyond simple calculus with del, divergence, curl, gradient, all del-based operations. Then the line integrals, one-dimensional, two-dimensional, three-dimensional, and interlinking line surface volume, Stokes theorem, Gauss divergence theorem. One to two questions you can expect on it. Typically in closed lines or closed surfaces or linking to Stokes theorem or to divergence or to gradient. That's another 1 to 2 questions. Collectively, if you now move on to differential equations, this is the most complicated area. Now onwards, maths gets slightly complicated because there can be different models in it. Homogeneous type, parametric form, convertible into homogeneous, or they could be simple variable separable method. They could be non-homogeneous, and second order differential equations are heavily asked. Second order differential equations with the d square minus m square equal to 0 or d square plus m square equal to 0 with knowing the roots, by knowing your eigenvalues, types of roots, that becomes a very crucial area. So differential equations is also expectedly 1 or 2 questions. And then comes the toughest topic, complex analysis, in which the basic operations like multiplication, divisions, powers, root of a complex numbers, anybody can handle it. The toughness increases as you go for complex integration, as you go for residual theorems, or if you go for Taylor series or Lorentz series, then the toughness increases. There's where actually start feeling it more tough. One question on basic operations, anybody can handle it. Complex analysis of divisions, multiplications, powers. Because we also use it for network theory, AC analysis. So I'm sure this is also within reach. Then comes the last and the most critical one, probability, in which it could be something based on your 12th class probability or your basic probability, conditional probability, picking up balloons or picking up dice or probability of throwing a die or coins, or it could move on to random variables, PDF, CDF. It could be more on understanding of what is density function and distribution function, or it could be something based on uniform density or exponential PDFs or other forms of PDF like Gaussian PDF, or it could be on statistics of mean, variance. So all these are probably expected to give you 1 to 2 questions. So all these topics, probability can be from 1 to 2 questions. There is a chance of complex analysis with 1 to 2 questions. It could be differential equations with 1 to 2 questions. On the whole, if you look at mathematics with around 5 topics, you can expect around 8 to 9 questions. So 8 to 9 questions are expected with 13 marks on an average from maths probability maths 5 topics. I hope it's very clear. Let's move on to the remaining 47 questions now. Let's move on to the remaining 47 questions and see how you're going to handle them. This is a small announcement about one of the crash course on electromagnetics, be my favorite area. So it's a small 10 hours course on electromagnetics starting on 6th February. 6th February every day for 2 hours for 5 days. So it's approximately for 10 hours. You'll be taught with all the topics of electromagnetics starting from basic static fields to advanced antennas. So it's a crash course because most students may have a necessity of revising it. So it's a small crash course. You can have the scan, you can scan it for registering, or the link I'll include it in the description. To attend it, I'll be taking all the 5 sessions in that. It's for enthusiastic students who are reaching up to EMT level, because mostly students may not be reaching to EMT level and may not be preparing. But if you have the standards to reach, do come to this crash course. Very useful for you. Yeah, now comes the first technical subject that anybody has got to prepare. That's network theory, which starts off essentially with basic DC analysis, which involves understanding what is KCL, KVL, symmetry in networks, star delta transformations, basic nodal analysis, mesh analysis. 90% nodal analysis should be sufficient. Rarely a question may need mesh analysis or any other such techniques, but it's basically about understanding dependent and independent sources, ability to handle DC analysis. Could be interlinked with DC sources which are dependent or maybe independent, could be interlinked with current sources, but basic DC analysis. Then after that, you should understand AC analysis by adding complex numbers to it. Because in DC analysis, we go only for real numbers. Only real numbers we handle as scalar quantities. Now AC, you could handle complex numbers with a phase also. So power calculations, resonance calculations, collectively you can expect 2 questions. So one from DC analysis, one from AC analysis, pakka sure you will be getting 2 questions from it. Then comes the theorems, of which majorly it is Thevenin's theorem, reducing the circuit through Thevenin's. and maximum power transfer theorem interlinked with Thevenin's. So they give you a question on maximum power theorem and ask you how do you get the total resistance or the maximum power condition for that resistance. Then it is Thevenin's theorem only. Reciprocity is also asked, but it's a very rare thing. So third question is mostly on Thevenin's or maximum power transfer theorem, rarely on reciprocity also. The fourth question should be on transients. Should be on majorly on DC transients, first order RLRC circuits. Rarely they go to second order or they go to more complex circuits where you may use Laplace or differential equations to solve it. 99% question may not need Laplace or differential equations. It could be simple first order circuit and the exponential solution. So you should understand and transient always to result in an exponential solution. It should be sufficient, but a rare chance where the question may be needing you to write a differential equation yourself and then solve it. Where there could be a second order chance, or it could be an RLC circuit, or it could be on transients, AC transients. So DC transients of first order, 90% should do it for the fourth question. But yeah, there is a chance of second order circuits and AC transients. Then comes the last question from two-port networks, which is basically understanding your AC analysis and DC analysis. Because they'll ask you what is the Z matrix of this network, or what is the Y parameter of that network, or what is the what is the H parameter of so and so network which is containing a dependent source. Because 99% they'll involve a dependent source and give you a circuit and ask you to find out its Z or Y or H or ABCD parameters. Sometimes they ask you to interconvert, they'll give you Z matrix and they'll ask you to find out H matrix, or they'll give you the Y matrix and ask you to find out G, which is not to by heart any formula but to analyze it on the spot. It could be sometimes interconnection of two networks. I got one network given with Z parameters, another network given with Y parameters. They ask you to interconvert it and get the resultant two-port networks. So interconnection of two two-port networks or interconversion between Z and Y or simple parametric calculations with the dependent sources could be the last question. So networks approximately worth around 4 to 5 questions with 6 to 8 marks. Mostly problems, no chance of any MSQs or theory is not really likely to be there. Uh, Multiple selection questions, it's a rare thing to ask in networks. Maybe they can give you a network and they say, find the power here, find the current there, and voltage there, and then they may give you all the three as options. Like there is a problem wherein you're calculating three or four things. And those three or four can be given as options. So that is one chance is there, but otherwise 99% they should be giving you a non-MSQ question only. So that's about your networks. First subject in technical with around an weightage of 4 to 5 questions or approximately 5 to 6 questions. It's your first subject finished. Let's move on to the other subjects. The second technical subject is moving on to electronic devices, analog electronics or simple EDC, which most of you feel it tough, but actually it's easy if you start with semiconductor physics. Understanding what is semiconductor, what is its temperature dependency, what is the effect of understanding doping, what is P region, what is N region, or what is the meaning of hole, electron. From there you have to start conceptually. So it's all about understanding the semiconductor physics of holes, electrons, doping, especially mass action law and energy bands, especially understanding carrier concentrations and Fermi level positions after doping. That could be a probable question, most probable question in the basics in semiconductor physics. If you escape from it, suppose if there's no question on it, the next chance is on your diffusion pakka sure. Linking diffusion with continuity equation, understanding how diffusion and a drift are sometimes equal. What is the effect of equilibrium of diffusion and drift? Such a question is possible. Rarely, of course, Hall effect, not a question in the recent years, but yeah, Hall effect, you got to learn energy, mass, and frequency, and understanding of E versus K curve, understanding of direct band and indirect band semiconductor based on that. That is conceptually also important. The probability is mostly on diffusion interlinking to continuity equation, or it could be on doping and Fermi level calculations. That's from semiconductor physics. But if you move on to diodes and analysis on diodes, it could be on the diode basics of the construction of the diode as to what is depletion region, what is the field inside it, what is step graded diode, what is linearly graded diode, and of course the diode VI equation, what is cut-in voltage, what is reverse saturation current, and what are the parameters that decide reverse saturation current, what is the meaning of I equal to I naught into E power V. So all these basic diode parameters, non-analog electronics, not applications, basics of diodes are likely to be there. And of course, you have to handle more such diodes, parameters like diode capacitance, what is diffusion capacitance, what is transition capacitance, what are the diode switching times, what is the meaning of transition time, recovery time, storage time, reverse recovery time, and all those things. There is a chance of a question even from junction capacitance. But 99% the question should be coming from depletion region and understanding of depletion region and the parameters of the diode. But yeah, sometimes it can be over on Zener basics. What is a doping and dependency on Zener voltage? What is breakdown? What is avalanche? What is the difference between Zener and avalanche mechanism? And the study of a lot of special diodes, maybe on something on tunnel diode, or it can be something on photodiode, or it could be on Schottky diode. So it's a chance, it's a rare chance, but yeah, mostly chance is on diode parameters or diode junction capacitance. That's majorly the chance. But if you move on from this area, the next most probable area in diodes in the ADC portion is solar cell. Solar cell has been repeated almost continuously for 3 years during 2021, 22, that time. Almost 3 years they've asked. So there is a good chance of asking solar cell its VI equation. What is the meaning of fill factor? What is its relationship with total maximum voltage or maximum current? The VA characteristics. So mostly they involve these things and ask you a question on solar cell. It is one probable question that you can expect. When it comes to BJTs or MOSFET, it's more interlinked to analog. I mean, core EDC level, you may not get questions on EDC, or maybe you may not get questions on BJT. Chance of asking the BJT's regions or the graphs and expecting you to draw the graphs of active region or saturation region. But yeah, I feel EDC is almost complete if you learn diodes, and of course, if you understand these things. And one most important question in EDC is undoubtedly MOS capacitance. In fact, MOS capacitance I've included in the next area. MOS capacitor is pakka sure shot one question. You can expect one question on modes of operation of the MOS capacitor, interlinking with its voltage versus capacitance, or width of the depletion region versus the voltage, or it could be charge accumulated versus the voltage. So MOS capacitance and modes interlinking with its inversion voltage, MOS inversion voltage, or it could be threshold voltage, interlinking with width of the depletion region. So there could be questions like that. In fact, it's one of the toughest area in EDC. So that's how you can expect 5 to 6 questions for around 7 to 9 marks. So totally we have come to a position where you can now handle approximately 10 technical questions, 10 to 11 technical questions from EDC and networks only. This is just a discussion of EDC and networks only. That's approximately 10 questions for us. Right? Let's move on to the next area, the analog electronics, which is now going to be more critically important. So MOS capacitor, diode basics, or your solar cell, this makes your EDC syllabus. Majorly, this is what makes your EDC syllabus. So coming to analog electronics, I feel there should be the first study on diode circuits and its applications. Could be clippers, clampers, rectifiers, filters, capacitor filter. No chance of asking on inductor filters. It's a rare thing, but yeah, inductor filters. But majorly capacitor filters, voltage doublers, regulator. These are all likely to have 1 to 2 questions. So diode circuits as a whole, understanding how diode fits in the circuit, how do you apply the Ohm's law or any KCL or KVL for that circuit in the presence of diode, whether the diode is on or off, those sort of questions are likely. In the applications of filters, rectifiers, half wave, full wave, bridge rectifier, voltage doublers, clampers, all these are Expected to have 1 to 2 questions. Then comes the most important area in analog electronics, the core, that is BJT DC analysis, which involves calculating the base currents, collector currents in CC or CB or CE configuration. Any configuration, any bias, cell bias, fixed bias, collector to base bias, any bias circuit will be given, any configuration will be given. You got to handle its operating point, the base current or whatever it is. That's one question, short for EC, preparing the BJT bias. If you escape from it, chance is on AC analysis, mostly on hybrid pi model, not on H parameter model, but H parameter model you have to learn. So calculating the gain or input impedance or voltage gain or current gain of the configuration with emitter capacitance, with bypass capacitance or without bypass capacitance, with emitter resistance, what is input impedance, without emitter resistance, what is input impedance, in cell bias, what is input impedance, and all these areas. So collectively from DC analysis, one question, and AC analysis, one question, you should be expecting surely 2 questions from BJTs, only on BJTs. Yeah, sometimes they interlink with current mirrors, they may interlink with multi-stage amplifiers, or it could look like a multi-stage amplifier question, but yeah, DC analysis, AC analysis, 2 questions. And of course, diode circuits, 2 questions. That makes it interestingly to 13 to 14 questions so far in the third subject. We're in the third subject. Then the MOSFET DC analysis of understanding linear region, saturation region, especially the E MOSFET equation, ID equal to mu COX into W by 2L into VGS minus VT whole square. These sort of equations based DC analysis, or they may interlink it with CMOS inverter. Sometimes it may look like a CMOS inverter question, or it may be a simple question on linear region and saturation region. One question is short on it. Sometimes, of course, they move beyond this to AC analysis, where you may have to find out the gain or the impedance, input impedance with some drain resistance, or sometimes the drain and gate may be short, or the gate and source may be short, or it could be an active load. Like instead of putting a drain resistance, I put one more MOSFET there involving active load. So it could be 3 or 4 MOSFETs acting as active loads, or instead of a source being grounded, there could be a source resistance, or the source resistance could be placed with an active load. So collectively, 2 questions can be expected. One from AC analysis of gain and impedance calculations, another from MOSFET, another from the basic DC analysis. That's what I expect. This is only a checklist. I'm not telling that questions will pakka come. Because see, when we have got around 100 concepts and 65 questions or 47 questions, this is a likely chance actually. This is what the order they got to follow. This is how they spread the questions. That's what I feel. So this is analog electronics. And of course, as I told you, the questions could be on CMOS inverter or current mirrors or feedback analysis or feedback amplifiers of series shunt, voltage series, voltage shunt, current series, current shunt. Frequency response, nowadays the questions are less. May not expect on frequency response, but yeah, there are questions on frequency response on FT calculations or F alpha, F beta calculations, bandwidth calculations, unit gain bandwidth calculations. There are questions on it, but yeah, of late the questions are reduced. This stage amplifiers you can expect. Maybe they may expect you to find some AC analysis of it, or they may ask you to find the transconductance of a resultant multi-stage amplifier, or they may ask you to find the DC operating point. Could be CECE, could be CECB, could be CCCC, could be the Darlington pair, could be the Cascode, whatever it is. There is a chance of asking questions on it. So collectively, I feel 2 plus 2 plus 2 around, we have finished around 5 to 6 questions. So let's say we have finished around diodes, 1 question or 2 questions. Then BJT is 1 or 2. So collectively, let's say 3 questions. Another one on one from this, around 5 to 6 questions we have finished so far. The remaining 2 questions or three, because 6 to 9 questions, let's say, could be on op amps, op amp applications. So diodes, BJT, MOSFET, op amp. With op amp applications of integrator, differentiator, low pass, high pass, they could be an precision rectifier or Schmidt trigger or summing amplifier or logarithmic amplifier or areas op amp applications are there. could be on active filters. So around two questions you can expect on overall op-amp applications. So ultimately, if you look at network theory, it's worth around 7 to 8 questions. I put it very low at 6 to 7, but you can say 7 to 8 questions from analog electronics overlapping with EDC. Mostly problems, mostly should be problems. Chances of theory questions also from maybe on linear saturation or some graphs. Chances of theory questions also. So around 8 to 10 marks. Collectively gives you very good weightage. So op amps, MOSFET, BJT analysis, and diodes should be a very good probability. That's broadly how you understand. And op amps, remember every application of op amp is important. Whatever application it has got, you have to learn every application. So that's about analog electronics, and we are in a position where we can handle now around 17 to 18 questions with network theory, EDC, and log electronics. Three subjects, around 17 questions. Still, we have to go to 47 questions. Still, we have to go to 47. We are right now at 17 question level. So, three subjects, 17 questions, and another 13 question 5 10 plus 8 18 questions from maths and aptitude. That means somebody preparing networks, EDC, analog electronics, and maths and aptitude can comfortably handle 35 questions. Three subjects, 17 questions. Maths aptitude, 18 questions. 35 questions you should be comfortably handling. That's how I feel GATE should be handled, subject by subject, question by question, right? So let's move on to the next subject. Next subject, let's see how you would handle it. So continuing with other subjects, remember this is checklist which I'm telling you probably just before you go to GATE exam. I'm not telling you to prepare anything new or anything, but I'm just telling you what are the probable topics and you did you go through these topics or not? Just telling you whether you have really handled them or not. Because some people learn about BJT too in depth and they forget to handle biasing circuits. They learn about too much of basics of unwanted semiconductor physics. They don't learn about Fermi level. So instead of all this deviated study, you should have a focus. And these are the areas that I thought you should be focusing. So it's just an idea for you. Do download our GatePro app. GatePro app from Play Store. Do download. I'll give you the links and everything. You can also purchase our courses for 2027. They're already there. And different subject courses are there. Electromagnetics is so available as a single subject. So almost we've got different options, test series. Do follow us in our YouTube channel. Hopefully we'll be doing more content. So in fact, it's a long time I've not done any YouTube, but yeah, we'll be doing more. So digital electronics, another easy area. Fourth subject, number systems. So decimal, octal, hexa, coded decimals, weighted codes, different codes, interconversion, given base 6, base 10, some other base, any other base, and then you conversion. So one question you can expect on number systems. One from the basic Boolean algebra of implementing, logic gates, implementing some small function, implementing some Boolean function through K maps, reducing logic simplification. So one question on basics, one question on number systems, short. Then one question on combinational circuits. Could be on address or could be on multiplexers most probably, or could be on coders, encoders, could be on decoders, encoders, parity checking circuits, could be on half adder, full adder, mostly on multiplexers. So combination circuits, one question. Then of course sequential circuits, flip flops, latches. How do you convert D flip flop to that flip flop, that to this interconversion, triggering counters, especially most importantly. Around two questions you can expect from sequential circuits. Though I put it one, it's approximately two questions. So one on flip flops, one on counters, one on interconversion, one on toggling modes. So around clarity, the syllabus is so clear. Number systems, Boolean algebra, combinational circuits, digital circuits. That's the level of clarity you have to reach. Now, in sequential circuit, there is a chance of missing clarity. That also I'm clearly telling you. Understand flip-flops, understand their interconversions, understand triggering and toggling, and go to counters. That should be mostly sufficient. Then, of course, one question on A to D converters, R to R ladder, or maybe on D to A converters, the counter type, flash type, successive approximation type. So A to D converters is equally important. So 1, 2, 3, 4 to 5 questions are very crystal clear. Combination circuits, sequential circuits, it's so clear. The last area, of course, is a slight confusion with the CO coming into syllabus of late for the last 4 years. CO is there. They removed a microprocessor. So then onwards, there is a confusion with the logic families also being not there. Semiconductor memory is, of course, getting important. And computer organization, one question coming in the last year, very easy question that too, but still you got to prepare. So this question is an doubt actually. This could be a slight enigma for us. But otherwise, the other topics are very clear. Could be from counters or sequential circuits or from combinational circuits. They are crystal clear. So overall, 5 to 6 questions, and of course, theory questions not exactly possible. But yeah, they could compare, or they can ask you to compare, different flip flops, or they could ask you to talk about the timing sequences, or they could be anything, slightly theoretically possible. It's around 79 marks possible from this, right? So that's approximately we are at a level where you're discussing 23 to 24 questions now. And I still did not come to the tough subjects. I did not start the tough subjects. 23 questions and 18 questions from maths and aptitude. It's comfortably, it's getting close to 50 questions. 65 total questions, almost 50 questions you can handle only with the digital, analog, EDC, and networks. Just see how simple is GATE exam. Then, of course, digital electronics, obviously, as I was telling you, is quite easy. We're going to move on to the tougher subjects. Let's move to the tough subjects now. Next subject is something that which most of you may not prefer to go through. Most of you may not like preparing. Certainly an advanced subject, but being my favorite, I just took it as the next subject. Otherwise, it should be control systems in the order. It should be control systems and then signals and then EMT or communications. But yeah, since it's only cross-checking, those are not learned EMT, please forward it and go to the next topic. Next 3 minutes or 4 minutes, forward it. But if you prepare EMT, what should you prepare? Since we also have a crash course and my core area is electromagnetics, I want to tell you that it's about vector calculus majorly. The first chapter is all about understanding vector calculus and coordinate systems. Direct question may not come on coordinate systems, but without learning coordinate systems, you cannot understand anything. 2 years back, there was a direct question on coordinate systems, on spherical coordinate systems. We learned vector calculus and coordinate systems and applied to Maxwell's equations. Understand what are Maxwell's equations of del dot, del cross, line integral, surface integral, triple integral, volume integral, and a chance on boundary conditions and Poisson's equations, capacitors, current, and continuity equation. 90% chance is not on the last topics, but it is on Maxwell's equations related area of Gauss law, charge calculations, or Ampere's law and current calculations. But everything interlinked with vector calculus. So one question, short from chapter 1, static electromagnetics. Then one question from electromagnetic waves. The wave equation. How do you understand Maxwell's time varying equations, time varying fields, time varying Maxwell's equations? How does that field suddenly become a wave? How does that energy become power? How does field propagate as a wave? What is the propagation constant? What is intrinsic impedance eta? How does it travel in lossless medium, lossy mediums? What is loss tangent? What is attenuation constant? What is its power calculations, polarizations? Most importantly, reflections, because reflections is a short question. So, how does a wave travel in 2 dimensions? How does a wave represent in 2 dimensions? Reflections at oblique incidence, Bruce triangle, all this put together one question you can expect. And the third topic is transmission lines. Expectedly on characteristic impedance or reflections. Topics are not widely spread here. They ask you on reflections, mismatch, or maybe on Smith chart, understanding of Smith chart, They are mostly on characteristic impedance and reflections. Rarely, of course, every 4 or 5 years, once they're asking on S parameters or maybe to matching techniques. So one question almost from transmission lines. Nowadays, the trend is changing actually. Instead of asking one question, as a checklist, I told this, they're asking two questions from EM waves and ignoring transmission lines. Asking two questions in antennas and ignoring waveguides. In fact, last 4 years, they ignored antennas completely. The questions were not at all on antennas. So they are jumbling the questions, no doubt, but checkpoint. These are the topics to check. This is only checklist. Then, of course, waveguides. Circular waveguides have been introduced in syllabus 3 years back. Not even a single question on that. Mostly on rectangular waveguides, cutoff frequencies, modes. It's about understanding the cutoff frequency for every mode. Actually, what is mode? How does a field look like in each mode? What are the field diagrams? What are the wave equations? What is phase velocity, group velocity? What is the wave angle? Mostly on rectangular waveguides. So these are the areas to look after. But majorly it's modes. Modes interlinking with cutoff frequency. Last is antennas. I'm really sorry to tell you that last 4 years or almost 5 years, there's no question on antennas. But hopefully, we should not ignore. It's all about understanding of wire antennas and dipoles. What is quarter wave monopole? What is Hertzian dipole? What is half wave dipole? What is folded dipole? What is its radiation distance? What is its gain? What is its vital parameters? Then goes on to arrays, broadside, end fire array, different types of arrays, different types of excitations, and of course, free space propagation equation. Free space propagation equation is more to understand, more to explain radar, satellites, antenna inter antenna communication. But yeah, one question maybe on antennas, one question maybe on waveguides. Sometimes two questions on waveguides and zero from antennas. Or sometimes it could be that you have two questions from transmission lines and nothing from waveguides. But yeah, these are the topics that you are supposed to go through. So overall, around 6 to 7 questions, 5 to 6 questions. Let's put it more simple. 5 to 6 questions, and one question even from vector calculus can be solved if you learn electromagnetics. So vector calculus also is interlinked to electromagnetics. So overall, if you see, I've come to around 29 questions level. 29 questions, so 30 questions you can answer in technical. What are the 47? Still three subjects left out. Control systems, communications, signals and systems. Three questions, approximately 17, three subjects, 17 questions, 29 so far. Hope you're getting it. So we have finished topic to topic checklist, uh, topic to topic checklist of networks, of EDC, electronic devices, analog electronics, digital electronics, and electromagnetics. So around 30 questions we have covered out of the 47. So we are going to cover three more questions, three more subjects, sorry, three more subjects and 17 more questions. So let's have a look at the next subject. That's what is control systems. Another short, expectedly simple questions come from control systems, especially from the understanding of transfer function of what is open loop, closed loop, how do you reduce a block diagram, how do you calculate the overall gain, how do you calculate with feedback and without feedback, how do you reduce a signal flow graph, how do you understand a block diagram and signal flow graph. All this short one question. The next question is mostly on stability analysis, on understanding of poles and zeros for a transfer function. Because poles and zeros for a transfer function will represent you at what frequency your transfer function is either becoming zero, there is no output, or the output is becoming infinity. So zero output or infinite output represents either complete instability or represents no output, attenuation. So for that, understanding the Routh array, understanding stability through Routh array is important. So second question is most likely on this. The third question is most likely on time domain analysis, understanding of damping, settling errors, Understanding of what is damping ratio, zeta, how do you handle root locus, different case studies in root locus. So first area most likely is the basics block diagram. Second is understanding of free poles and zeros, understanding of stability. Then third area is of course understanding of damping, root locus. Fourth area is also similar, which is frequency domain analysis, in which you'll be doing stability analysis through gain margins, phase margins. You go for the Borda plot or polar plot or the Nyquist plot. So 4 questions to 5 questions you can expect on these areas. And the last, of course, on compensators or controllers or state space analysis, understanding of what is controllability, observability. How do you understand a block diagram converted into its state space model? How do you convert a signal flow into state space model? So 5 to 6 questions and a very easy subject, simple subject. So maximum chance of problems only. Theory questions are very rare here. Maybe theory questions may not be really possible here, but MSQ chance are also very less. They're framing, of course, nowadays more on MSQs, but still, you are now handling approximately 35 questions. That means you are in a position where you have to handle 35 plus that 18 of maths and aptitude, around approximately 53 questions out of 65. You're hardly 12 questions away from the entire paper. And all this, remember, it's only a checklist. I'm not telling you anything about how many questions you should score or anything. I'm just telling you a checklist. Check out, did you go through these topics or not? Check out whether you can handle it or not. Right. Now it's time for signals and systems. Signals and systems starts with understanding of signals, types of signals, and properties of shifting, properties of signals by multiplication, scaling. Similarly, system properties, what is causality, what is stability, what is convolution of signals. So around 1 to 2 questions on this. So all types of signals and signal properties and system properties put together one question. Convolution could be one more question. So around approximately 2 questions on the first basics. Then it goes with Laplace transforms immediately, understanding of the properties of Laplace transform, applying them for different conditions, finding out inverse Laplace transform or simple Laplace transform, or sometimes on ROC and region of convergence problems. That's second area. This is also very important area and short. You learn Laplace transform and the properties of shifting, property of scaling. Sure, you have to get a question on it. The third question, of course, could be most probably on continuous Fourier transform or discrete Fourier transform. Could be on either CTFT or DTFT. So that could be the third question, and most likely that's a trend that's being followed, not compulsory. But Z transform and ROC is one short question. I mean, in discrete transforms, Z transform is mandatory. They may not ask too much on DTFT or other discrete transforms, but Z transforms is important. And of course, discrete Fourier transform is important, one question. And the last question, most likely on samplings, Hilbert transforms, correlation and miscellaneous areas. There's also one chance of asking questions on all these areas put together, one question. Like if they ask you sampling this year, next year they may ask Hilbert transforms. So around 6 to 7 questions and 79 marks. Theory questions, I think it's rare. Unless and until it is on basic properties, they may ask you some theory questions. MSQs, there is a chance, no doubt. They may frame some MSQs on some signal property or something. So there is a chance of MSQ, but still, I don't pull it out. So we are at almost 40 questions now. 47 questions together, 40 questions, and the last is communications. So I hope the signal systems is clear. I hope the areas are very clear. That's how I feel we have reached around 40 questions. Let's go to the remaining last communications. So coming to the last subject and the last set of questions, it's communications. Electromagnetics and communications have become a rare subjects which most people are not preparing. But as a checklist, I've just told you. But communications, at least the analog communication should be simple. Preparing on EM modulation index, understanding different EM mechanisms like DSBSC, SSB, their power calculations, the bandwidth calculations. This should be quite simple area. But the problem with communications is they interlink this with noise. So once it interlinks with the noise and complex calculations in digital, there it's very tough. But analog electronics, with these basics, one question surely can handle it. That's amplitude modulation and such things. And the same may continue with one more question on FM modulation, generation techniques, demodulation techniques, bandwidth and Carsel's rule. So overall, I don't think any student should find difficulty in simply on analog communications of AM modulation or FM modulation being two questions. The toughness may start when we go for receivers or when it question comes with the noise. Especially if it is only on receivers, it's not a problem. But when they interlink all this with the noise, the third question is most likely to be tough, or the toughness may increase as you go to digital communications, especially when you go to PCM, PM, quantization errors, quantization noise, or when they're going for sampling errors or sampling and Nyquist criteria, then if they interlink with the noise, obviously it's going to be tough. But otherwise, as such, the concept is simple. I mean, the questions are getting tough, but otherwise, digital communications as a subject is not tough. The questions and the style could be tough. So, going from baseband to band pass communications, the shift keying techniques, the ASK, FSK, PSK, where a digital signal is actually transmitted in analog form, right? In analog form, they transmit. That's what is band pass modulation. Understanding of the constellation diagrams, and again, if they interlink with the noise, the problem starts. As long as it's not interlinked with the noise, it's simple. But constellation diagrams and PSK rare, but sometimes they interlink with the noise. So that's where four questions, five questions are likely. So digital communication starts, toughness starts. As long as it is on analog communications, it's simple. But digital communications obviously makes it tough. Then the last area, of course, is in information theory. It could be an entropy calculations or channel capacity, Shannon-Hartley's law, or it could be on source coding or error correction coding or Hamming codes, block codes, or it could be on Shannon-Fanon coding or any source coding technique. One or two questions are expected. That completes the complete list of 47 questions and checklist. It was actually not a completely simple checklist, but it is areas that you're supposed to focus and go. Did you go through this area or not? That's what I've checked. You go through any previous year paper, this is going to be there. So thank you all. Thank you for being with us. But it's a lengthy video made it, but it's comprehensively complete in every topic in GATE. It'll serve as an excellent checklist. And thanks all of you for following. But please like and encourage us. We'll make more such videos. But don't expect a video every one day or every 2 days. We'll do it whenever we feel the content is important. We'll feel it whenever the content has got some stuff to be given. We'll do it whenever we feel this video is not there or some necessity is there. I'll surely be doing. But if you like and subscribe, it'll encourage us. Certainly, it'll encourage us. So follow our channel, like, and also download our GatePro app. GatePro app comes with recorded classes. Right now, the app comes with excellent offers, the pre-gate offers, because post-gate, the price may be different. So download the app, check out study material, check out test series, and go through our recorded classes. Myself, Suresh VSR, teacher in electromagnetics. I've been there in GATE for the last 25 years, teaching for GATE ECE electromagnetics in different institutes. My videos in antennas are very popular. I've got quite a few viral videos in antennas. Do watch them. Search out for VSR Suresh. You'll get all my details. So Suresh VSR, GatePro. Pro. Thank you all. Take care and like and subscribe, students. Thank you. Hope the checklist is very interesting. And I'll upload this file in our GatePro app. If you want to go through the checklist once again, do download our app, and the download is directly from Play Store, or you can scan this and download the app. You can go to Play Store, and if you just say GatePro, you'll get the app. Download it, and thank you, students. Thank you for following us. Take care. Goodbye.